Okay, so we are already to Unit 8, and in Unit 8 we're going to talk about similarity. So with similarity, mostly you have to be good with solving proportions, or have a good understanding of proportional reasoning, which means equations where there's a fraction on one side and a fraction on the other side. So when we talk about similar polygons, we're going to use things called similarity statements. It's up in the objectives up here. Use similarity statements. We're going to find corresponding lengths in polygons that are similar, and use similarity to talk about perimeter and area. So this first little piece, this paragraph, talks about corresponding parts of similar polygons, and it says in the diagram, triangle ABC is similar to triangle DEF. And we can write ABC is similar to DEF with this symbol. It's one kind of squiggly line. ABC is similar to DEF. And a similarity transformation preserves the angle measure, so corresponding angles of similar shapes are congruent. A similarity transformation also enlarges or reduces the side lengths by a scale factor k, which is going to come in or factor in later. So corresponding side lengths are proportional. So if we look at ABC to DEF, let's say we did a scale factor of 2. That means the side lengths of DEF are twice the side lengths of ABC. The other way around, if we reduced it, the scale factor would be a half. So the corresponding angles, A and D are congruent, A and D are congruent, B and E are congruent, C and F are congruent, okay? And the sides are multiplied by a scale factor, all by the same scale factor. So we're going to get an example about similarity statements, and we are going to find the scale factor from RST to XYZ. So if we're going from triangle RST to XYZ, the triangle is getting smaller. So we call that a reduction. So this is a reduction. And the reason I write reduction is because that means for our scale factor is going to be a number smaller than 1. So to find that scale factor, I'm going to take a length from XYZ and divide it by a length from RST, a corresponding length. So I'm just going to do 18 divided by 30, okay? And you can represent this in 2 different ways. 18 divided by 30, simplified as a fraction, is 3/5. Or, similarly, you could just do 18 divided by 30 is 0.6. If you try this with the other side lengths, you could do 12 divided by 20. You'd get the same thing, 0.6. 15 divided by 25. But essentially, you always think you take in the similarity statement, you take the second shape's side length divided by the first shape's side length. So if this were the other way around, that would be an enlargement. Okay, so that's the first part of it, is finding a scale factor. The second part is listing the pairs of congruent angles. And really, you just have to look at which angles correspond to each other. And I go back to the similarity statement. So, angle R is congruent to angle X, because they are both the first angle in our similarity statement. Angle S is congruent to angle Y. They're the second angle in our similarity statement. And then angle T is congruent to angle Z, because they are both last in our similarity statement. So that's the second part, is identifying the congruent angles, which that part I think is the easiest, because it's just the angles that line up in the similarity statement. It's not necessarily the angles and how they look in the diagram, because they may not, the shape might be rotated. So you've got to go by the statement. So I was going by this up here. I'm going to highlight that, our similarity statement up top, right? And then the corresponding side lengths in a statement of proportionality. So that's kind of from the top what was shown right here, is writing these all as a ratio, okay? Writing each of these pairs of side lengths as a ratio. So I should keep our similarity statement up there. But if I'm looking at, let's just start with RS, the first segment shown in our statement. RS corresponds to XY. So the ratio of rs to xy is going to be the same as the ratio of st to yz, okay? Because those are corresponding sides in the similarity statement. So rs, xy, st, yz, and then finally rt and xz. So corresponding sides written as a ratio. So you notice all of the side lengths from RST are on the top, all of the side lengths from XYZ are on the bottom, because that ratio is the same. So when I talked about scale factor, if we divided this way of all these sides, all of these ratios are the same. They'd all come out to be the same decimal if we divided them. So a quick guided practice, I'm asking you the same things as up top, I just didn't put the ABC there. So you are finding, scale factor, okay? You are listing the corresponding, or congruent angles. And then you're finding the ratios of the sides. So take a minute, find those measures, or answer those questions, and then I will go through the answers with you when you're ready. Okay, so for this example, I just wanted you to understand, I wrote enlargement for the scale factor because we are going from triangle JKL to PQR, meaning all of the side lengths, corresponding side lengths, get bigger, okay? So to find that scale factor, I took a side length from PQR, divided it by a side length from JKL. So I just picked 6 divided by 4, which is 1.5. And if you would have done 9 divided by 6 or 12 divided by 8, you would have gotten the same number. So I got 1.5 for the scale factor. And for the scale factor, I'm going to use the letter K. Okay, that's a common letter to use for scale factor. I'm not sure the origin of why. I can research it for you if you want to. Congruent angles, just setting the corresponding angles as congruent. J and P, okay, K and Q, and then L and R are corresponding, so they are congruent. And then the ratio of side lengths, JK and PQ are the same ratio as KL to QR as JL to PR. So it's like you're thinking of corresponding sides. Corresponding sides are the same ratio. So KL and QR, 4 to 6, okay? And if you wrote this the other way, if you wrote PQ over JK, QR over KL, or PR over JL, it'd be the same thing. It'd be the same thing. So if you wrote either of these, I would accept either as your ratio of side lengths, okay? Because as long as all the sides from JKL and PQR are on the same, either all on the top or all on the bottom, we're good. So the next part of this lesson is to talk about corresponding lengths, finding the value of a corresponding length, okay? So in this example, I'm asking you to find the value of x, okay? So the value of x. So x is this length. And the thing to know here is for the value of x, I've got to find what side is corresponding to x. So I look at the other triangle, MNP. The side that is corresponding to x is the side length of 30. So what I'm going to do is I'm going to use a proportion, okay? So I'm going to write a ratio of x and 30. And I'm going to set that ratio equal to, and I'm going to pick 2 other sides. Now, one of the ratios I'm going to use, or I could use, is 15 and 18. Okay? I could write that proportion. Alternatively, I could write this proportion. I could still use x and 30. I could also use the proportion of 20 and 24. I could do that as well. So, to solve this, I multiply 18 by x and 30 by 15 and set them equal to each other. So 450 divided by 18 is just 25. And you're going to notice I get the same value for x with the other proportion. 24x equals 600, x is 25. So either way I set up my proportion, I'm gonna get the same value for x. So it's knowing what proportion to set up and then how to solve it. If you use the fish method, that's fine too. You could have done, see if I remember how to do this. 13 times 15 divided by 8 is x. You could do the fish method for that as well. So in the last one, a little more tricky. Finding the altitude PS. PS is this length, okay? So I'm gonna give PS a variable. I'm gonna make it x. So my proportion here, okay, I'm gonna compare x to 20, okay? I'm gonna put a ratio of x to 20, okay? And I think of those as like corresponding lengths, okay? And then in the other ratio I would set up, I could do this a few different ways. I could do a ratio of 12 to 16 or 6 to 8. Okay, 12 to 16. So I can set up a proportion where it's 16x equals 12 times 20. And that is 240. 240 divided by 16, x is 15. So these altitudes are a ratio, and then these sides added together would be another ratio for those two triangles. So those are corresponding. So I can solve that. So now I'm gonna do the guided practice, and I'm just gonna show my work. I'm not gonna explain, but I'm just gonna show my work. So if you want to ask me personally how I did it, or where you went wrong, if you got it wrong, I will help you with that.